Today we'll be looking at section 4.3, and here you'll see the two main objectives that we'll be looking at. First, you want to be able to find the six trig functions, and by the six trig functions I mean sine, cosine, tangent, cosecant, secant, and cotangent, given any ordered pair. Second, I want you to be able to find the six trig functions given information about trig functions. While these sound similar, they are a little bit different. We'll look at examples today of how they differ. So until today, we've been given like find the sine of 60 degrees or find the sine of 390 degrees or those types of things. We've been focusing on the unit circle or we've been focusing on just a triangle out in space. Today, now that we're looking at these types of problems, we're going to move to a coordinate grid. So as you can see here, this would be an example of Objective 1. We're going to evaluate the trig functions given a point. It says let theta be the acute angle. Remember, acute means between 0 and 90 degrees in standard position whose terminal side contains the point 3, -5. So terminal side would be the end part of the angle. We're going to find the six trig functions. Now, as always, when I'm doing problems, I like to draw pictures whenever possible. Again, because they're giving me an ordered pair, I need to draw my grid. Now, the ordered pair is 3, 5, which means I go over 3 on the x-axis and down 5. It's the point right here. Anytime you're given an ordered pair, you again need to make that what they call the terminal side. It's connected from the origin to that point. Okay, so we talked about how we've already been working with triangles, and this really is going to be no different. Sorry about that. This is really no different than that in that we're still going to make a triangle. Here's the key. That's going to be the hypotenuse of my triangle. So the line from the origin to the point is always the hypotenuse. Connect your triangle to the x-axis. Okay, so I'm going to draw my triangle here. Now the theta that the problem is referring to, that's always that reference angle. We talked about reference angles when doing our unit circle, and again it's always the angle between the x-axis and the terminal side. So that's my theta. Now if I think about this as a right triangle, which it is, this would be a +3, and since I went down 5 here, I'm going to label that leg as a -5. Now hopefully, now that we're thinking about a right triangle and we know the two legs, I'm hoping that the Pythagorean Theorem is popping into your mind, because that's what we're going to use to solve for the third side. So I'm going to use a squared plus b squared equals c squared, where my a can be the 3, my b will be -5, and I'm ultimately going to find the hypotenuse. Gives me 9 plus 25 equals c squared, 34 equals c squared, and now I'm going to take the square root. Now the hypotenuse will always be positive, so c equals the square root of 34. Now that we have our right triangle, it becomes a problem, just like in sections 4.1 and 4.2. We're given that triangle, I want to find sine of theta. Again, the key is that the theta is the angle here. So we know sine is opposite over hypotenuse, so I'd have -5 over square root 34. Don't forget to rationalize the denominator. I multiply by root 34 over root 34. I get -5 root 34 over 34. Now, reminder, when we're finding the six trig functions, I always like to think of the two pairs. So I know that sine and cosecant go together, and remember these are called reciprocal functions. So I go back to the original, -5 over square root 34. Cosecant then is root 34 over 5. Now I find the cosine of the theta in that same triangle. So cosine of theta is adjacent over hypotenuse. My adjacent side is 3 over square root 34. Again, I would rationalize the denominator by multiplying by root 34 over root 34. I get 3 root 34 over 34. Again, the reciprocal function to cosine is going to be secant theta. I go back to the original and take the reciprocal, so it's root 34 over 3. And finally, I find my tangent. Tangent of theta is opposite over adjacent because it's TOA, so I'd have -5/3. Therefore, cotangent of theta would be -3/5. Take the reciprocal of that. As you can see, once we get the triangle set up, it's very similar to problems we've done in the past. The key is that you will now have some negatives, so you have to figure out the correct quadrant.